Okay, super excited to be here. Beautiful place here, but I do have to start this talk with a little bit of bad news. So for all of you that were wondering, unfortunately, the slide advances. There we go. There are still servers in serverless in 2022. I know we're working on it, right? Maybe next year we'll see how that goes. But actually today what I want to talk about, we're going to start and sort of go through how serverless has evolved over the last 7 years. We're going to look at how the workflows and the responsibilities of developers have changed. We'll take a quick look at the tools, services, and the patterns that we've created over the last 7 years and what we've got with those now. And then we're going to talk about the groundwork that is being laid for the future of modern applications. And we have a great panel after this with Matt and Brian and Rob. And we're all going to talk about sort of what is next, what's after Jamstack, what's after serverless, and so forth. So that should be pretty interesting. So my name is Jeremy Daly. I am currently the GM at Serverless Cloud, or of Serverless Cloud at Serverless Inc., the creators of the serverless framework. I have been consulting with companies for quite some time, actually started a long time ago, so I do have gray in my beard, and I finally stopped dyeing it, so that picture's a little out of date. I started working with AWS in 2009, back when it was like EC2 instances. That was fun, and then Lambda in 2015. I blog. I have a blog at jeremydaly.com. I have a number of open source projects. I obviously just speaking. I publish that newsletter every week, and I am the founder and co-host of the Serverless Chats podcast. And I have been doing a lot of things, including trying to create this DynamoDB modeling course, which is taking longer than I have wanted it to. But if you're interested in modeling NoSQL databases with DynamoDB, go sign up for the newsletter there. And I'm also an AWS Serverless Hero, which is a great program that AWS offers that just kind of gives us some insights so we can go in and actually see what they're building and give them some feedback on that stuff. So anyways, I usually start every presentation with a quote from Werner Vogels that says, everything fails all the time. It just gets us in a good headspace for building serverless applications and distributed systems. But a bit of a humble brag here. I did have Werner on my podcast not too long ago. And I love this quote where he says, I still get annoyed by every piece of AWS that is not serverless. Now, the funny thing is that Werner's definition of serverless might be a little different than mine. It might be a little different than yours, and it probably is pretty much different for everybody. So we're going to talk about that a little bit as well. But I want to go back early before the serverless era. So let's call this the pre-serverless era. So these are the days, the beginnings of AWS, 2006 to 2014. So S3 launched in 2006, in March of 2006. Shortly thereafter, SQS went GA. And then it took 3 years. I don't know what they were doing for those 3 years, but to launch CloudWatch. We got SNS the year later. We got CloudFront that year, along with Route 53, which it does, global DNS. We got CloudFormation in February of 2011. And if anybody is wondering what you did before there was CloudFormation, we were using the console and writing bash scripts like a bunch of chumps. That's what we were doing. So DynamoDB came around in January of 2012. And then we got Kinesis a year later in 2013. And the reason why I wanted to mention all of these services is if you look at this list of services, these are sort of some of the core serverless services that AWS has, but this is all before serverless even existed. So all of this foundation, all this groundwork, or all this, this foundation was laid well before we got to Lambda functions in November of 2014. So once we got past that, we kind of got into the next 2 years, and I call these the wonder years, because we were really wondering, what is this new paradigm? What can we do with it? So in 2015, right after Lambda went GA, API Gateway was launched. Now, Lambda actually launched originally without the ability to invoke it via HTTP in any way. So you basically could connect to a S3 bucket event. There was Kinesis connections. There were a couple other things. But if you wanted to invoke it with HTTP, you actually had to call it with the AWS SDK using what was called the Lambda API. And then because this new sort of paradigm existed where they added API Gateway, and now you could call a Lambda function, use it to back an API, the serverless framework, originally called JAWS, That actually came into being, the first version of that was published in October of 2015, and they actually invented some pretty interesting things. It was presented at reInvent in 2015, had quite a bit of fanfare. So anyways, interesting, just interesting bit of history there. But anyways, Jamstack, which was coined by Matt Billman, who will be on stage next, this sort of came around. And this is the point in sort of the cloud where APIs, the API economy, you hear that term a lot, that was kind of coming about. And while all these people were building applications with, and APIs with serverless, there was no way to connect to a database, right, other than DynamoDB or something that used HTTP connections. So for a year, or more than a year, people were building applications and they weren't even able to connect to RDS or some sort of cluster. Now, once they added this, it was pretty bad. It was slow. It was, there was all kinds of connection problems, but we don't have time to get into that. About the same time, Azure Functions hit the market. Athena came in November 2016. The interesting thing about Athena is this is one of those underrated services, but essentially this is probably one of the most powerful serverless services that AWS has, because this can look through all of your S3 data and actually query it just like a SQL server. Is pretty impressive thing. AWS SAM came out in November 2016, trying to build up, as a way that wasn't using the serverless framework to do this. And step functions were launched in 2016 as well, giving some orchestration capabilities. And then what AWS was doing at the time, and I am doing this very much so in the context of AWS. I think AWS led the market here. They're the ones who really sort of guided what we consider to be these modern serverless anyways. But they created this thing called the Serverless Application Lens, which was a way that, which is tied to the well-architected framework, which essentially was trying to explain, okay, over the last 2 years, here's how people have been building serverless applications. This is what we think they look like. So that was their first sort of foray into trying to codify and give you some ideas of how to build serverless applications. Now, we get to the end of 2016, there's a whole bunch of things that have been added, but there's a lot of use cases. So you've heard all the complaints like, I can't do GraphQL, or I can't do this, or whatever. So in 2017, there were a whole bunch of things that happened to really expand the use cases. Now, first of all, again, bit of history, this is when Google Cloud Functions came into play. FaunaDB, Rob Sutter will talk about that, but some people got their hands on the Calvin paper and thought it'd be a good idea to build a database that followed those rules. Architect Framework, which Brian LaRue will also be on stage next, so that was something that he co-created and is currently maintaining as well. And Google Firestore, this is the only one I marked as beta simply because Google leaves things in beta for so long. I'm not even sure it's out of beta yet, but no, it is. I think it took 2 years to get out of beta, but Gmail might still be in beta, I'm not sure. And then AWS Amplify was created. So this was another attempt by AWS to try to find a way to explain and codify how people should be building serverless applications. Now, when this came out, this was at the same time that Fargate came out, so serverless containers. So already we're starting to kind of mix what we mean by serverless. AppSync came out, so the ability to do GraphQL with a dedicated service. This service came out in 2017 as sort of a pairing with AWS Amplify. And then Aurora Serverless, the first sort of attempt to make relational databases accessible by serverless applications. This came out in 2017 as well. Again, it was very cool, all kinds of problems with any of these new technologies, but not that big of a deal. It's still cool technology. Now, serverless application repository, this is another step, and I put these ones in, the idea of the lens and Amplify and the application repository, because knowing how to build these applications, things are constantly changing. You're always adding new technologies, new capabilities. You've got all kinds of people that are complaining that you can't do this, you can't do that. I get cold starts, whatever. So these are ways that AWS was trying to help codify how you build serverless applications. So this came out now, serverless application repository. I'm not even sure it's still there. It didn't work very well. All right, so then you get to the end of 2017, you've expanded some use cases, and the biggest issue that we had, though, was that everything that you were building with serverless was essentially net new. Right? So you were building new GraphQL APIs, or you were building APIs, or even doing things with CloudFront and S3 and whatever. And we're starting to build some really interesting things, building on the Jamstack and all that kind of stuff. But the problem is that if you had existing applications, which most people did, most people that were willing to try serverless were people who were already using the cloud, it was very hard for them to integrate their existing applications into serverless. So in June of 2018 is when we introduced SQS as a trigger. Now, I want to think about this. SQS is a massively scalable queue service, handles billions and billions of events probably every day. I'm not sure of that number. I don't check my math on that. But this is one of the first services they launched. And for 3 years, it didn't have the ability to actually pull from a Lambda function other than running it on a schedule, which was terribly inefficient. So this was interesting because a lot of companies were using SQS as an event bus, and so they were sending events to this and they couldn't integrate those with serverless systems. So when this came on, this was actually a pretty big step. Google Cloud Run came into the picture there, just as an aside. A company called Nimbella, so Roderick Rabba, who was one of the original creators of OpenWhisk, and what eventually I believe came IBM Cloud Functions or whatever they call them. He started this company. This was interesting. This was another sort of container-based, similar to Cloud Run type thing entering the picture there. Lambda expanded to 15-minute timeouts, right? So you had a lot more processing capability behind the scenes. They introduced WebSockets, they introduced Lambda layers, which gave people the ability to sort of share precompiled code so you didn't have to install that in every Lambda function, and also the runtime API, because some people were like, hey, I really want to run PHP on Lambda. And surprisingly, there were people who did that, and you got breath out of that, actually. So, and then the application load balancer came in, and this is another thing. If you're thinking very small and you're thinking about serverless and net new serverless applications, it's easy. You just put an API gateway up, and you can route all your traffic to API gateway. But we had companies that I was consulting with, as well as others that we saw, that basically had these massive workloads that are using EC2, they're using all these other services, and the problem is they couldn't find a way to route traffic to their serverless applications or split that traffic. So it was either API gateway to an ALB to their old traffic or to their old system, and then put the API gateway in front for the Lambda functions. That was terribly inefficient, a lot of latency. So when application load balancer support came on, actually created a way for larger companies that had existing workloads to start using a strangler fig pattern and start routing some of their traffic off to their serverless applications. So that was actually sort of a big step. So we get to the end of 2018, we've got all these integrations going on, but we're still missing a few major components for serverless to kind of complete the full serverless picture. And remember, right from the beginning, serverless was very much so event-driven. So in May of 2019, we got the data API, which gave you a way to connect to Aurora Serverless via HTTP, no more VPCs. VPCs eventually got better, but at that time they were pretty rough. And then sort of the Peace Day Resistance, I don't know if that's the right way to say it, but anyways, Amazon Event Bridge, which was a enterprise messaging bus that was essentially an evolution of CloudWatch events. This came out. Now this sort of changed the game in terms of how people were now routing information between different services. So this opened up a really good possibility, not only for existing applications, but also as a way for serverless applications to start building out better microservice architecture. AWS CDK, that was announced at the same time at the AWS New York Summit. And then we got Lambda Destinations. And I should go back to Lambda Destinations for a second. So this is one of the things where AWS, I don't think, likes to say they make mistakes. They're not infallible. And Lambda Destinations was one of the first things where it's almost like a correction. So there's a thing called dead letter queues in asynchronous functions, which basically if the function fails, it will send whatever the event was or whatever the failed event was, it'll send it to an SQS queue for you or SNS topic or whatever. So they added Lambda Destinations, which gave you more control of asynchronous functions. You actually got more information. So they had two conflicting ways to do things. They also invented or came out with HTTP APIs, which was a rewrite of API Gateway that was a lighter weight version of API, the REST version of the API, because again, it was less expensive, it was more performant, lower latency, and so forth. And then because the connection methodology from a Lambda function to a database was so hard and so complicated, there's an issue with connection pooling. You can't do connection pooling from a Lambda function. So you had to have all these open connections to a database, and whenever it scaled, your database would not scale with it. They came up with RDS proxy to sort of fix that issue. So they were trying to fix some of these things, get us to a point where things got a little bit cheaper, a little bit more managed. We finally get Event Bridge. So we get to the end of 2019, and the problem is now we have all these primitives, we have all these things that we have to do, and Xavier Lefebvre wrote this article about the typical serverless architecture. This was early 2020. And a lot of people were like, well, that looks way too complicated. And it is kind of complicated. If you follow the diagram, it's not too bad. But essentially, this is what we got to with serverless applications, that in order to build a full serverless application, there was a lot of wiring. There was a lot of configuration. There's a whole bunch of things happening there. And it became this sort of typical serverless developer experience where you start off with this hello world example, very easy to do. You use Architect, you use serverless framework, you use SAM, you use whatever, and you can create these very easily. But then when you start looking at real-world production serverless applications, they quickly grow into these massive diagrams, and people get very, very frustrated. So after that, people are still using it. People are building, people are learning. There's tons of blog posts going out there. This is the movement. It's happening. But again, as people started building these complex architectures and investing a ton of time in these architectures, what ended up happening is they started bumping up against constraints. And they finally figured out, like, well, yeah, if I can only do so much processing, or if this is the timeout here or whatever. So there were a bunch of constraints, and there was also the issue where you had existing developers now trying to port some workloads over to serverless. So in 2020, this is sort of where a lot of these constraints got removed. I mentioned CockroachDB came on the scene as well as another potential solution for a database, because that still wasn't solved. But we got State with Lambda EFS integration. We got Lambda extensions, which gave us more control over the lifecycle events. And that was big for observability companies being able to read things like when it timed out, or being able to ship logs and some of that stuff. Lambda container image support came along, basically saying, well, everybody loves Kubernetes, right? So if people are building containers, let's go ahead and make it so we can move those containers over to a Lambda function. It's not quite 100% compatible, but it works. And what they did with it is they expanded it to 10 gigs for a deployment size, which is pretty big. We also got 10 gigs of memory for Lambda as well. So some of these larger processing needs, some of those constraints were lifted. And then we got a new version of Aurora Serverless that was supposed to solve all the problems of the old Aurora Serverless. I have a Twitter thread on this where I disagree with that, but hopefully it'll eventually get there. But regardless of sort of where all these things are, there's so many primitives out there now that if you're a serverless developer, you need to know these primitives, right? So let's look at the serverless framework just as an example, because I don't pick on the company I work for. But essentially, if you want to create a function, that maps directly to a Lambda function. If you want to create events, you have to say, I want to pull off SQS, or I want to read off Kinesis. You need to know the primitives. You have to map them to those primitives. And then any other resources that the framework doesn't support, you just have to create and use raw CloudFormation. Now, Architect, which is the framework that Brian maintains, Brian LaRue, I think they did a much better job from the abstraction level, where they didn't necessarily tie it to a specific service, or they didn't necessarily tie it to a specific vendor. But again, it's still very much so, like, you want HTTP, well, that's a Lambda function. Or you need queues, that's SQS tables, DynamoDB, and so forth. Right? So it still ties you to the primitives, and there's still some configuration you have to do that are specific to the primitives that you're using. Now with AWS CDK, you're still defining all those resources explicitly, and you still need to know those configurations. Now, there's something called constructs, if anybody's familiar with the CDK, that does allow you to do this cool thing where you can actually create, I think they're level 3 constructs, whatever they are, but you can sort of codify those use cases and take a lot of that configuration and wrap it up into the use cases. And actually, Pulumi has a very similar thing called component resources where you can do that as well. So even so, you're still at some point in that code, even if you're using those constructs, you still have to know what they're doing underneath. And more importantly, you're still responsible for whatever gets deployed. So even if you have these nice use cases packaged up for you, in all of these situations, these are actually deploying infrastructure that you're responsible for as a developer. And this is one of those things where it's like, you have all of these resources, you have all of these primitives, you have all of these tools to build things, and really you can build pretty much anything you want to. The problem is that it's very likely that you're going to build it wrong. And so serverless developers now have new responsibilities. So it's not just about writing business logic. And again, this has changed quite a bit, right? So I don't want to say, like, if you're building EC2 or building containers that you're only focused on business logic. This is probably true for more of the more modern applications. But you're also responsible for sort of that cloud architecture and knowing what resources you need, knowing the limits of those, making sure those are properly configured. You have to do build and deployment pipelines. So your code is very tightly coupled to your framework that's actually deploying and configuring architecture. So that's part of you now. It's no longer like I write some code, I check it in, and then somebody else is completely responsible for how that gets deployed and what resources that uses. Monitoring observability, this has been a huge topic. There's a couple vendors out there that do this. This is something where, as a developer now, With distributed systems, you have to test in production. There's no other way to test, right? So you have to be able to see what's happening, because a few users hitting up against a dev environment is not going to show you where the holes are in a distributed application. So you need to have monitoring and observability built in to your code. You have to have it built in. You have to be able to monitor that and see what happens. And then if something breaks, you're the one who's responsible for it, because an ops person isn't going to know the details of what you're running. And then the other thing is security and compliance. We no longer have tools that are above, that are now network rules that can block things at the firewall level. Very much so, a lot of that AppSec is going to fall on you as a developer. And this sort of brings us to this new paradigm that we've seen slowly, where the idea is the cloud is better than you at a lot of things, right? And so rather than you writing all this code like you normally would in a single server in a monolithic type application, if you're doing things like error handling or retrying failures, the cloud does that for you now. Or if you're managing failover and redundancy, you don't have to write that in your scripts. If you're transporting data, or in some cases actually transforming data, there's all these services that do this for you, and they're much more efficient and much more stable with all the retries and all that kind of stuff that are actually part of the cloud services that actually do this. And then if you're orchestrating workflows, we used to write a lot of orchestration in just code, and we would say, do this, then do this, call this, if this comes back, then fail. Whatever. The problem with doing that in the cloud, especially with something like a Lambda function, is that there's too many opportunities for that to break, for that to fail, and for you not to know where that state is. So if you're orchestrating workflows, this is something that we encourage now not to write in a Lambda function. We want this to be done in a state machine like step functions. And the thing is that even though you're moving a lot of that code into configuration, even if it's IAC, even if it's infrastructure as code, CloudFormation, or Architect, or Serverless Framework, or SAM, or any of these things, that code is still a liability, right? And the thing that bothers me a little bit about configuration over code is the fact that that code can quickly become technical debt, especially when they add new features, they add new services. Your code, your infrastructure's code doesn't necessarily adapt to those new services that are there. So in terms of sort of understanding these patterns and how, which configurations we need and what are the right way to do things, this is something I posted in 2018 originally, end of 2018. There's a whole bunch of patterns there. I didn't make most of these up. These were just things that I saw, things that I was using, but I kept on asking myself, I'm like, am I doing this right? Is this the right way to do this particular thing? And surprisingly, this got a lot of good feedback. People were like, oh, that's how I was doing it, but I wasn't sure, and so it just started a lot of conversations. So this, I think, was really great. We got a lot of good feedback just in terms of how things are supposed to be built. And then this followed on where this idea of creating patterns and trying to figure out the right way to do things, this sort of caught on, and Matt Coulter from Liberty IT, or Liberty Mutual, I get the two confused. Anyways, he created this thing called cdkpatterns.com. He was working with Dave Anderson and Mark McCann, trying to get Liberty Mutual to adopt serverless. And so the problem was that it was so new still, even in 2020, that people weren't really sure what are the right patterns. Like, is this going to work? Are other people doing this? So by creating this CDK pattern site, he actually did a really good job of bringing the community in and getting buy-in on what types of patterns people actually wanted to use. And then about a year later, maybe a year later, the developer advocate team at AWS Serverless, they created this serverlessland.com pattern site. This is a great resource, by the way. This has 100 patterns and with a whole bunch of templates and whatever. And this really goes into detail showing you how to configure certain things, and at least gives you a template and a starting point to do some of these things. But here's the problem. Even though there are starting points, you can still go in and change stuff. So, how do companies go now? How do companies now actually make sure that they can not only create what the standard or the pattern is going to be, but also enforce it within their organizations? Now, Christy Peralt's going to speak a little bit later about Liberty Mutual, but I do want to mention this, trying to take too much of thunder away, but essentially, they've created things called serverless enablement teams, where essentially they codify those patterns, the CDK patterns, to try to enable day 2 pattern usage from new team members, meaning that all of that complex learning, all of the compliance, all of the stuff that you really need to know, the nuances of how a particular pattern works, it's already codified in the CDK, and they can just go ahead and use those patterns and deploy them on day 2 so that they can get productive right away. And Lego has something called the Platform Squad, and what they do is this is to basically introduce and maintain those standards around everything from compliance to shared code, how observability, make sure things are checked off, the observability is there, and so forth. Really interesting, and it would be great if everybody had teams that could do this for them. Unfortunately, most companies don't, especially startups, small businesses, even companies that are just getting into serverless. So even if you have people that know this stuff, again, it takes time to develop this out. So 2021 was an interesting year because we saw a lot of companies trying to address the problem of complexity and say, these patterns are too complex, but we already know what they are. Most of us have used these patterns that have been in this, been doing this for a while. We know what these are. Let's figure out a way to combine the patterns. Or combine those primitives into patterns and create abstractions around those. So App Runner came out, which was a way to sort of just deploy containers more efficiently. Step Functions came out with their integrations to the AWS SDK. Amplify Studio came out, which was more a visual editor to create apps. And then a bunch of little things happened. Partial batch responses, event filtering. They launched a whole bunch of new serverless services like serverless inference and Kafka serverless. And then we got Lambda function URLs, and we got 10 gigs of ephemeral storage. These were all great things. These happened early this year, but they were supposed to happen last year. But while that was happening, Serverless Stack launches their new version that supports CDK constructs in there. IBM Cloud Code Engine comes out. PlanetScale launches in beta, I think in May or something like that, to address the ongoing serverless data issue. Akka Serverless launches as a new platform. Serverless Cloud, which is the product that I'm working on, was launched. And then I'm going to say this wrong. Zata? I don't know. I'm going to try that. I've been trying to figure it out in the green room. But anyway, Zata gets launched I think they launched their beta September or something like that, as a new go-to serverless database. So there are a lot of people getting into the space to make it easier and a little bit simpler for people to do these things. And then meanwhile, Nimbella was bought by DigitalOcean, assuming DigitalOcean wants to get into the serverless space as well. So that brings us to sort of now, which I like to consider as the post-serverless era. Serverless is whatever you want it to be. It's more of a mindset than it is any set of technologies. But I look at it now in terms of where we want to go. We have everything we need to build modern applications. And that's really what this next era is going to be about. It's going to be about building modern applications in the cloud. And modern applications in the cloud may contain containers. They may have serverless things. They may be using other services and managed services and so forth. But essentially, modern applications is where we are. So I just want to go through quickly a couple of these sort of where we've landed with a few different things. Pre-configured infrastructure platforms, so App Runner, Nimbella, as I mentioned, and IBM Cloud Code Engine. These are all things where you kind of just throw some workloads at them and they kind of figure out how to scale based off of that. They're a little bit restrictive. Edge computing platforms, so like Cloudflare Workers or Fastly, these are things doing edge compute. Great for low latency stuff, globally distributed. Some have KV stuff, limited execution times though, so they're better for lightweight workloads. So we're still not necessarily running our full applications on these, but great for things like edge compute. And then Jamstack is now moving to meet serverless, but also moving to the edge, right? So you've got SSR, SSG, ISR, whatever other acronyms you can think of. These are all happening now as part of serverless functions, as part of edge functions. They do things like framework detection, deployment management for you. You get both the serverless and edge functions there. And then this idea of integrated backends and extensibility, Netlify is doing some really cool things with Netlify Graph. They also have edge functions running on Deno now. So some really cool stuff happening in this space. If anybody was here yesterday, you may have saw Sean Wang mention this idea of self-provisioning runtimes. So this idea that a paradigm where everything that your program needs, all the infrastructure you need for your program, can actually be generated from the code. So you don't actually have to write any specific code. So again, he calls this the self-provisioning runtime. I'm running out of time, so get through these quickly. But actually, when he wrote this, I don't think he realized how far along this was. There are a lot of companies in this space now that are actually doing this, including Serverless Cloud. And while he calls it self-provisioning runtime, something that we call it is infrastructure from code. And essentially what this is, again, you write application code only. There's no YAML or configuration files, at least for cloud resources. Maybe for your front-end frameworks, you still are going to need some of that because we haven't gotten rid of those yet. but you focus on use cases and outcomes as opposed to writing specifically against a primitive. You're using familiar patterns. It automatically deploys and manages the infrastructure to support your app. And then again, simple workflows to do your testing and your development and your deployment. And then this is the coolest piece of this. If you write the abstraction in a way that's more about use cases, then what primitives it uses behind the scene doesn't matter. So one function or one particular API route might get deployed to a Lambda function, but another one might be running in a Fargate container, sorry. Or, again, maybe it's Kubernetes or whatever it is. The point is the way of building these applications doesn't care about the infrastructure it runs on, it only cares about the use cases that it needs. All right, so quickly modern architectural patterns. So event-driven applications, this is something where, especially with EventBridge and whatever, these are all very much so a modern way of building apps again. Orchestration, stateful apps. If you are communicating across microservices, oftentimes event-driven works just fine. But if you have workflows that run within those, payment processing, fulfillment, things like that, having a stateful component there and using something like step functions is much preferred. Now, Jamstack is still a very viable thing. People are building on it, but as we've seen, it continues to evolve. We're moving to serverless, we're moving to edge functions, different ways to do that. Self-provisioning runtimes, maybe not an architecture pattern itself, but certainly something that is being explored heavily. And then I want to mention functional web apps. This is something that Brian LaRue and his team is working on or is sort of defined. And this is the idea of cloud functions doing the work for generating the actual HTML behind the scene and being able to rather than you deploying static things, you actually generate dynamic templates, but you can do it in cloud functions. This is really interesting because Lambda functions are great for serving up HTML. And you can control all kinds of cool stuff with API Gateway and with CloudFront, where you can actually control how much, how long something's cached for, whether it's just cached for the user, whether it's cached in the CDN. So interesting things there. Okay, so the state of serverless, just some key takeaways here. It's evolved tremendously over the last 7 years. It's only been 7 years, so I'd say it's not your grandmother's serverless, but she wasn't using it. So it's evolved a lot in the last 7 years. So if you looked at it 3 years ago and you look at it now, it's completely different. So much has changed. The vast majority of the objections, a lot of people make a ton of objections like, cold starts and this, and I can't do that, whatever. So a lot of those have been addressed, something also to look at. If you need to do anything, whether it's ML or it's database or whatever, there's most likely some sort of primitive or managed service for you that you can use. Configuration over code, again, not this trend that I like, but this is where it's gone to, where, again, let the cloud do more of the heavy lifting for you. Event-driven applications, they're back, right? So if anybody was doing programming in the 70s with mainframes, you probably did event-driven applications. Well, they're back, and that's what we're using now. And then growing complexity is still a major concern, for me at least, because it keeps getting complicated, and I think we have to move in this direction of simplifying it and building better abstractions as opposed to having to worry about all those primitives. So overall, I would say that the state of serverless is strong, but there's always more to be done. So anyways, that is my talk. Check out my blog, podcast, newsletter, course, and sign up for Serverless Cloud, and let me know what you think about that. Thank you.